Hello fellow CNCnutz, and welcome back to part 2 of building my vacuum table. In the last episode we created the base and the top for my vacuum table, and I gave it a wee test. It had really excellent sideways holding force, but I wasn't too impressed with how well it held the material on the table itself. There's something not quite right there, and I hope to get to that before very long and solve what's going on there. But not only that, I want to see if I can make some improvements. A previous table I made had a whole heap of pockets on the top, and I want to recreate that and see what difference, if any, that actually makes. While we're at it, we're also going to check out the vacuum I brought for this project. Find out whether it's any good, adequate, or no good at all. So with that, let's jump into it and get some testing done. So one of the comments I got after the last video was that I should seal the edge of my top MDF to stop air being pulled in the sides, and I actually agree with that. In fact, I've already done it on the original one. But the question is, what difference does it actually make? So to find out, what I've done is I've made a whole new board here. I haven't yet skimmed it on the top here. It's been skimmed on the bottom to open up the MDF. But I've left the top intact here. This does not have as good a suction as the original one I made. And I'm just going to run this incense stick around here, and we'll see if we can detect any smoke being sucked into the edges of our MDF, or anywhere else for that matter. So here we are looking at the edges of the MDF, and as you can see, the incense really is showing no interest in it at all. If I come over here to the hole where the screw goes, I can see some of it being pulled into this hole. Put the screw into the hole and we'll see what difference it makes now. With the screw in place, no air is being drawn into this hole. Now in the previous build I did, I found that smoke was being pulled down into these slots because it was coming through the back of the MDF and congregating in the slot area here and being sucked through. But as you can see here, the smoke has no interest in going down at all. So if we come to the center of the table here, you can see the smoke is actually rising up off the table. It really isn't being sucked down to the table at all. I'll just change tabletop and we'll see what effect that has, if indeed any. So this is the tabletop I used in last week's episode. I've been around and I've painted the edges. I painted underneath to just past where the O-ring is, so I get a good seal on it. Anything beyond that O-ring is sealed with paint. Above here, that's also been painted. I've got my 6 screws in this time because we know that air can come out through these screw holes when the screws are missing. Let's turn the vacuum on full power and just see how much smoke is being pulled down to the table. Well, there we go. It really doesn't look that interested in being sucked down onto the table. So one of the things I wasn't very happy about with this table at the end of the last episode was just how easily this here lifted up off the table. There didn't seem to be any major downward force on it at all. Certainly took a lot of effort to drag this across the tabletop when the vacuum was on, but when it came to lifting it, it came up so easily. So after that, I started doing a bit of thinking, and then I realized I'm not actually lifting this off the table, I'm peeling it off the table. And the two things are entirely different. When I'm peeling it, I'm just lifting a small corner here and then I can gradually lift the whole thing off. As more air gets under there, the easier it becomes. If I have a sheet of MDF here and put that on the table, I think the story will be entirely different. Let's turn the vacuum on and see just how easy it is to pull both these materials up off the table. So with the vacuum on full, there's plenty of sideways force, but it comes up really easy. There's just no resistance there at all, really. Let's try a bit of MDF. This has got melamine coating on it, so it's going to hold right down. No, it's actually plywood. There's a bit of slippability on there. Could be the fact this is so shiny. I don't know, but let's try lifting it. Certainly takes a lot more force to lift this. A lot more force to lift this up off the table. So what, if anything, does this really tell us? If you're going to be doing testing, you need to be using the right equipment. Simply grabbing a piece of thin, flexible PVC is not going to do the job. You need something rigid on the table so you can take some decent measurements with it. So I'm now going to do some tests, and for that I'm going to be using this here. It's simply a piece of MDF, and I've put a mounting point on it so I can fit a scale to take some actual measurements. So here's my test equipment. It's a stick which I'm going to use to apply even pressure when I pull on the scale here. This will give us the reading to show us just how much pressure or force there is required to move this here. And this is nothing more than a piece of MDF. It's been painted. I've sanded it as smooth as I can get it so I get the best possible seal to the tabletop here. I've added to it a piece of angle iron with a hole so that I can put my scale through it, and then this goes through the handle. With this here, we'll be able to see just how much force it takes to actually move this across the table or lift it. So for the first test, I have the vacuum turned off. I'm just going to pull on the scales here, and we'll just measure how much force it takes to normally move this piece of MDF across the table. And we're looking around about 1 pound. Now for the next test, I'm going to turn on the vacuum, and in this test I'll be checking the different power levels of the vacuum. I'll be doing it at low, medium and high power. From now on it's going to get a little bit noisier. So this is low power, and I'm getting around about, we'll say 20 pound of force required to move this across the table. So now I've taken it up to half power. Let's see what we get this time. There's about a 10 pound, we'll say 30, about 35 pound of pressure required to move this across the table. Okay, this time we're on full power. Make sure that's 0, which it is. So that's somewhere around about the 40 to 43 pound of pressure to move this across the table. The best increase came at around about the mid-power range, so I'm going to do all my tests on that range from now on. It's a lot easier on the vacuum. For this test I put a sheet of newspaper down between the tabletop and my test board. Let's see what difference that makes. When we were doing this earlier, we were getting around about the 30 to 35 pound required to drag this across the table. Vacuum's running at mid power. Well, as you can see, adding newspaper definitely makes an improvement there. We went from, say, 30 to 33 pound up to possibly 50, definitely 45. So adding newspaper definitely makes a difference to this setup. So the last test I'm going to do before I modify the tabletop here is a vertical lift test, and I'm going to do it first without any vacuum on, and then we have 1.5 pounds is how much it takes to raise this up off the board. Now turn the vacuum on to half power. So about 7.7 pound of pressure to lift this up off the table now. So the last one I'm going to do, I'm just going to take it up to full power and we'll just see what the difference is. .6 is about 1 additional pound. So again, not a huge difference between maximum power and half power. So again, I think running the vacuum at half power is suitable. Okay, so far so good, and there are 3 takeaways from my testing so far. The first is that painting the edges of the MDF really doesn't seem to make any difference if the smoke test has anything to say about it. It's definitely not being drawn into the material. Though, that said, I'm going to continue painting the edges and just underneath around where the O-ring is, just to make sure I've got the best seal there anyway. It's definitely not going to hurt. Second, adding newspaper between the stock and the table surface makes a big difference in holding power. Now, I know there are specialist materials out there designed to do this here, which will work even better, but newspaper's commonly available. Nobody has any trouble finding it, and it does such a good job. Lastly, running my vacuum at half power rather than full power gives around about the same holding power. Not quite as much, but it doesn't really justify running the vacuum at full speed. Plus, of course, I don't want to burn out my vacuum cleaner, I only just got it. We'll come back to the vacuum later and just see how running it at different speeds actually affects the vacuum itself. Okay, well next I'm going to make some changes to the tabletop surface. Always wanted to check out what happens if I put pockets into the surface of my table. Does it make any real difference? Let's find out. This video is sponsored by Masso's CNC controller. Masso can run mills, lathes, routers, plasma machines, and more. Simply connect your stepper or servo motor drives, a monitor, keyboard, mouse, and pen drive with your G-code. No PC required, giving outstanding reliability while eliminating driver and motion card compatibility issues. Masso, the PC-less controller. Powerful, stable, guaranteed. So now that the tabletop's finished machining, I've screwed it into place. I've been around underneath and painted the edge to give the best O-ring seal I can get. I then also painted the edges here and on top, and I colour coded it so that I'd know which one was which. Of course, by now you've obviously spotted the flaw in that plan. Don't know what I was thinking colour coding them. If you're colourblind, you won't be able to tell them apart. The first test we want to run is the smoke test. I'm curious to see, does it pull the smoke down into these holes or not? Let's give it a try. So with the smoke test here, what we're seeing is the smoke isn't really being pulled down very hard, but we will see it disappear into the hole. So it is being pulled down, unlike when we didn't have the holes on here. So I'm hopeful that's going to give us a lot more pull. Out of curiosity, my previous board had holes drilled in the centre of the hole. So on this one, I have drilled a hole right through to the bottom. And as you can see here, there's a lot more vacuum pulling the smoke just down. There's no smoke coming up off the top. It's actually all being funneled down into the hole. So no real surprise there. Each of these little ports here have their own tiny downdraft. If I drill a small hole in the bottom of each port, I'll get more of a downdraft. But those holes don't actually improve your vacuum holding. It just means it can pull that vacuum on the port here a little bit quicker. But it also means the more of those I have uncovered, the more I'm going to lose my vacuum, which is why I didn't drill holes in the bottom of these ports like I did on the previous table. We all know just how porous this MDF is. It doesn't need any more assistance to lose vacuum. So with that done, it's now time to put the test rig on and see what results we get from that. I've got the vacuum going at half power like on my previous tests, and the first test I'm going to do is the lifting test to see what sort of result I get. Around about 9 pounds before it broke free, so that's pretty good, but not a great improvement. See what the pull test has for us. Around about 23 pound mark is when this started moving across the table. So let's now move on and try it with newspaper between the surface of the table and the material. Again, we'll do the lift test. That's 14 pound of force required to lift that off. We'll just give it another try. Yep, 14 pound. So let's see what happens now when we pull it. About the 33, 35 pound mark, it pulls along the table. So for this test, I've covered up all the unused holes. I've put this plastic sheeting over it, which won't let air through. And I'm just going to try the lift test. About 17 pound required to lift that off the table. So next, I'm going to do the horizontal pull test. And there we are, we're about the 48 mark, and it's starting to flip across the table. There's one last test I want to run. It's to do with this foam packaging material. This stuff's about 1/4 of a millimetre thick. It's waterproof, so air doesn't go through it. I've laid it over the surface of my table, and then I've gone through with a screwdriver and I've poked holes in the ports that I want or that will end up underneath my material here. And I'm just going to lay my board down on top of it. I'm hoping this will provide a much better seal between the bottom board and this here. Being foam, hopefully it's got a little bit of give. So again, I'm still running my vacuum at the half speed. And let's see how much lift we have. There we have it, 20 pound, and I was able to lift this up off the table. Let's now try a horizontal pull. And it's just starting to slip now, and that is at 61 pound. So it looks like we have a winner. This particular arrangement, the board with the ports already machined into it, in conjunction with a material like this here, seems to give the best holding power for the vacuum provided. So this stuff I said before was about 1/4 of a millimetre. I think I'm wrong. I think it's 1/2 millimetre thick. So in store I have actually seen this stuff available in 1, 2 and 4 millimetres. I might have to order a roll and give it a try and see what else I can do with it. I did try other foam. I had this piece here. Air definitely goes through this here, but that's its problem. You can't pull a vacuum with this, so this type of foam is no use. Now, one of the advantages of using a foam material is that boards like this, here's a piece of plywood here. This particular one could not actually vacuum down to the table, but by adding that piece of foam, I could get this to hold. Using newspaper, it wouldn't hold on the surface. That said, I'm actually going to keep both tabletops, this one with the holes and without, and give them a good try and see how they actually work under real life conditions. Why do I want a vacuum table? And that's the main question here. It's to hold thin sheet material so that I can cut it, because when you stick material down on the table, thin material does tend to bow up off the table, which makes cutting it quite difficult. If you want to do any engraving on it, then it's almost impossible. The other reason is if I want to flatten a material, then I can just sit it on the table, vacuum it down, and then just skim across the surface to give me a flat reference. Okay, let's now look at the vacuum. So this is the vacuum I decided to purchase for this project, and if I ever find time, to clean up my workshop. It's a Karcher Wet and Dry vacuum, and it's the WD-6P. It seems to be the higher end model in their range, though it's not a professional vacuum cleaner like the likes of a Festool. What I brought it for really was the fact that it actually had the power outlet on it that I can attach to my sander, and it will automatically start when I start the sander, because I've got a bit of work to do on my house. It also has this here, the dial, so I can dial up how much power goes through the vacuum here. Now I've taken some power measurements on it just to see what it does. So with the hose connected, I'm pulling 1600 watts. It's rated at 1300 watts. Once I actually cover up the end of that hose, it's pulling 1300 watts. If I drop it down to half, I'm pulling 750 watts. That's 50%. That's 1 horsepower. And if I take it a little bit higher up, it'll pull 1000 watts. Now I also did some temperature measurements on it, and I found that if I run it continuously as a normal vacuum, it gets up to about 56 degrees, somewhere around about there. If I run it at half power, or just a fraction over that, it will keep running at about that 56 degree mark, maybe up as high as 60. If I run it at full power connected to the vacuum table though, it will overheat, and it gets actually a bit too hot to actually even touch, so don't even go there. The vacuum may be rated at 1300 watts, but it's probably not rated to run continuously at that rate. So you need to really know what the duty cycle the manufacturer would expect you to be using it if you're, say, using it for sanding down your house or similar. I'm going to be conservative and say a 50% duty cycle, maybe a little bit more, so I think it's safe to run in the 50%, maybe a fraction higher than that, but I would not be running this here at full power. And the other thing is, if we remember back to when I did the tests, running it at half power gave the same vacuum holding force as pretty much running it at full power. So I think that's the sweet spot for this particular vacuum. If you want one that you can run continuously, then I'd probably start looking at something like a Festool or one of the really high-end vacuum cleaners. But I think this is going to do it for me until at least I can maybe find a proper vacuum pump which is actually designed for running a vacuum table. Now, one of the comments in last week's episode was to do with the size of my hose. It was suggested that using the larger hose rather than the smaller one here would give me a better vacuum. I did some testing and found there was absolutely no difference at all. I think the thing here is that the holes in the MDF are absolutely microscopic, that this here can easily keep up when using the smaller diameter hose here. Another suggestion was maybe use the dust collecting vacuum to provide the vacuum to the table. But that doesn't really work. The dust collector just cannot provide enough suck for this particular project. Would I suggest this vacuum cleaner here as the answer to the vacuum table question? Well, not really. It's not designed for it. The best thing for a vacuum table is a vacuum pump. I think it's pretty good, and I think if I get the right setting here, and I think halfway is the right setting, then it'll work fine. One thing I will tell you for sure is that if you're not using a wet and dry vac, then you will burn it out, because the normal vacuum cleaners do not have separate cooling paths, so will simply overheat because they're not getting any cooling. Plans for those of you who want to make my vacuum table, I'll put a link in the description box below this video that will take you off to my website where you can download the drawings for this particular table. Why not make one yourself? And that's where I'm going to leave this episode. All that remains me to do is to thank you guys for watching. Don't forget to like and subscribe. And I'll catch you guys later. Cheers.